Today we are going to have a look at the problem of speech synthesis and acoustic reception features. This is a re-recording of an earlier talk that was given before the University of Kerala National Seminar on the same subject. Linguistic studies have been, by and large, remained confined to historical and descriptive linguistics. Of course, it was resilient to impact from other intellectual developments such as sociology, psychology, computer advancements, and information technology. However, it is with the advent of the phenomenal and exponential growth in information technology that a significant revolution in communicative linguistics has commenced. This transformation is reflected in the explosion of a number of research projects on theory and applications of speech synthesis as well as audio signal processing. Gunnar Font, an electrical engineer from Sweden, was one of the great pioneers to whom credit must be given for initiating this area of interdisciplinary research. It is significant that on listening to him during a seminar at Harvard, Roman Jakobsen got a spark to enlighten his theory of distinctive features of language sounds. This basic approach, distinctive feature analysis, has been followed by many applied studies in MIT Boston, Universities of Chicago, Columbia, UCLA, at Los Angeles and Berkeley, and many other phonetic laboratories all over the world. A specific mention must be made here of the work of Ben Gold and Nelson Magan, whose classical treatise on speech and audio signal processing has been extended to perception of speech and music by Dan Ellis of Columbia University, published in October 2011. It is a significant coincidence that this seminal idea about the seminar that I am addressing now occurred to the head of the Department of Linguistics in Kerala University at about the same time after attending a text-to-speech seminar at the CIIL Mysore. And I hope such researchers would sprout like pineapples in Kerala. This area of psychoacoustics and computational linguistics is being researched through an interdisciplinary approach in many places in India. Some of them are Deccan College, Pune, the Tata Institute of Fundamental Research, Mumbai, the IIT in Hyderabad, the major IITs in Kanpur, Madras and Mumbai, the Indian Institute of Science, Bangalore, and the CIIL in Mysore, and the All India Institute of Speech and Hearing in Mysore. This underscores a valuable understanding that speech and music are just the two sides of the same coin. One may say with pardonable pride, music without language will be dumb, and language without music would be deaf. Shakespeare has vouched for it long ago. I quote, He that hath no music in himself is fit for stratagems and spoils, unquote. The objective of this study is to examine the vital importance of all the innovative studies in integrating speech production and processing as well as reception. Can the satellite-oriented computer technology and other Android modes of communication be programmed to meet the challenges of these specific needs and objectives and resolve some of the major issues in acoustic cum auditory interlocutions? Some of the background studies in this subject are very interesting. Eminent phoneticians like Daniel Jones, Abercrombie, Gimson, Kenneth Pike, Peter Ladefoged, and Gunnar Font, and great linguists like Roman Jakobson, Noam Chomsky, Maurice Halley have been concerned with the structure of speech sounds. It was given to Font to make a concise statement to define a model of speech. He said, "The speech wave is the response of the vocal tract to one or more excitation signals." This understanding led directly to acoustic engineering methods to separate the source, namely the excitation signal, from the filter, that is, time-varying vocal tract. This procedure for implementing this kind of separation is called deconvolution. Thus, a speech wave is a linear convolution of source and filter. This understanding of human speech enabled Gunnar Font to an analysis synthesis of the parameters so that a suitable machine model could be produced. The very first voice coding was known as vocoder. This was the earliest synthesizer produced in Sweden. In the field of speech synthesis, very good groundwork has been carried out by James Flanagan, Andrew Hunt, and Alan Black, who published a paper called, I quote, "Unit Selection in a Concatenative Speech Synthesis System using a Large Speech Database." This has been published in Acoustics, Speech and Signal Processing, 1996. What contributes to the innovations now is the impact of the series of path-breaking developments in the area of information technology communication. The future trend of applied linguistic research will in all likelihood get intertwined with such technological interdisciplinary studies, which might be a major part of our fieldwork. Gunnar Font had the vision to anticipate this likely outcome long ago. We would like to now take up a brief survey of some of the major research work in India. The TIFR Mumbai is a pioneer in this field, and it has published a very interesting course material under the title Fundamentals of Speech Recognition, a short course that was offered by Dr. Joseph Piccone. The prerequisite for training to understand and appreciate all the features of speech synthesis involves a thorough understanding of articulatory phonetics, acoustic phonetics, and auditory phonetics. The IPA, the International Phonetic Association, registered about 100 years ago, has evolved a system of symbols based on the criteria of point of articulation, manner of articulation, besides the position of the tongue. Technically, these were called phones. It classified human speech into broad categories of consonants, vowels, semivowels, etc. In addition, it set up a uniform system of indicating stressed syllables within a word. Different intonation patterns provide a clue to the meaning of words, phrases, and sentences. Different intonation patterns provide a clue to the meaning of utterances. This uniform standard has been the basis for Daniel Jones and Webster to work on their monumental reference dictionary, which are considered models of RP in England and standard East American pronunciation of English in America. Modern digitized dictionaries provide a pre-recorded sound support for each root word based upon the system of phonetic transcription used. Not all dictionaries use the same uniform system of transcription. Beyond a sentence, we may require prosodic indications to make out the meaning. For example, the expression, "That's interesting," can be bland, curious, inquisitive, and even demanding for more communication depending upon the intonation pattern chosen. Suffice to conclude that sounds and the manner of grouping of the sounds is only one way of understanding human communication. There is much more to associate with the meaning than the use of mere sounds. These features are broadly termed suprasegmentals, or those features we are beyond phonemic notation. We would like to now take up alphabet, Timit, and WorldBet as the systems of notation to study speech. Alphabet 1970, developed to support ARPA research in the 70s, is an advanced research projects agency funded by the Defense Department of the United States of America. Hence, it is also known as DARPABET. The objective was to perform 1,000 word automatic speech recognition by making use of a few speakers, connected speech, constrained grammar, and allow less than 10% error. Only a system called Harpy, built by a CMU graduate called Bruce Lowry, fulfilled this enormous project. Timit, so called because it is a research program funded by Texas Instruments in collaboration with MIT laboratories, is a variant of ARPABET. WorldBet has been developed recently by Jim Hieronymus of AT&T Lab to deal with multiple languages within a single ASCII system. A clear understanding of these systems would enable the researcher to do a good job. Another interesting visitor to TAFR was Mr. Richard Stern from the Department of Electrical and Computer Engineering and Language Technologies of the Institute of Carnegie Mellon University of US. His innovative analysis is contained in his transcript uploaded by TAFR proceedings under the title New Directions in Automated Speech Technologies. This paved the way for machines to become part of communication. With the growth of understanding strides of artificial intelligence, this became a significant cornerstone of research. Recorded telephonic messages and replay systems come under this category. I would love to refer to an interesting introductory talk by Simon King, which is available in YouTube under his name, which gives a beautiful introduction to the problem of speech synthesis. Professor Perry Bhaskar Rao of Hyderabad has taken the concept of speech synthesis forward in his team research in the Language Technical Research Center in the International Institute of Information Technology, Hyderabad, which inter alia has published a bunch of useful research findings on the multifarious factors of speech communication and signal processing. Perry Bhaskar Rao's illustrations show, I quote, divergence in text-to-sound rules in Indian languages, unquote. His observation on the Indian languages that, quote, there is a false impression that there is a similarity of text-to-sound rules sets in all Indian languages, unquote, needs be closely examined and be put to test with reference to other major Indian languages and well-known dialects as well. However, cognitive similarities and dissimilarities cannot be conveniently ignored by all researchers. The specially commissioned editor of Sadhana, Dr. Yajna Narayana, has done well to highlight different models of speech communication and signal processing in his special edition. The prevalence and convenience of so many models should provide ample choices to the Indian researchers. Current applications as reported in the media in India. Some time ago, in the course of 2011, we came across a news item in the Hindu that a Chinese researcher has invented a new kind of pen that has been specially programmed to read Holy Quran in a specially formatted edition. Without any knowledge of the Arabic script or its orthography, one may hold the pen at the top of the pages of this special edition of Holy Quran, and the pen does the rest of the reading or recitation of the contents for the benefit of the holder. Here is a good instance of script-to-speech synthesis. How is it achieved, and what model has been followed? Could this be applied equally to other texts in other languages? These are unanswered questions that need further research for finding a suitable solution. According to yet another news item that appeared in the media on Friday the 29th of July 2011, namely the Hindu Thiruvananthapuram edition, page 3, a new software tool called Swaram has been invented, and this can be used for listening to any written work in Malayalam. According to Shri V. Rijoy, developer of the software, he says any type of file that supports the Unicode format can run on this program. The scope of this program includes integration of a portable document format, namely a PDF converter for documents in regional language. While this is doubly useful for theorists as well as the practitioners of language teaching, further applications need be scientifically studied in greater linguistic and mechanical detail. Suffice to say, here and now, this needs a well-coordinated and clearly aimed interdisciplinary research effort. It's a wonderful coincidence that such technological innovations are happening all over the world, and it is high time that researchers, applied linguists, engineers, and field workers come together and make a thorough study of speech synthesis and acoustic speech processing. It is very interesting at this stage to point out a very interesting report that appeared in an English newspaper, The Guardian, of July the 2nd. Have a look at the paper. In this report, it is ascertained that a lot of research work has been put into the building of a program called EMS. EMS is a technical name that was given by a professor of music analysis, and he has created a software program that would help creating an artificial composition of music. This is something very unique and has been done for the first time, and when this gets released to the people in September 2012, many eyebrows in the field of orchestral music are going to be raised. In conclusion, I would like to say that it is high time that artificial intelligence and acoustic, speech and music processing, as well as speech synthesis, are given due prominence. Thank you for listening.